like to introduce Isa and Uday, who will be co-presenting Automation for Operations, T-Mobile Journey. Isa is a senior member of technical staff at T-Mobile, specializing in large-scale network design, automation, and infrastructure operations. With over 18 years of industry experience and as a 3-time CCIE, he focuses on reducing operational complexity and improving network reliability at scale. Isa has previously presented at NANOG, sharing hands-on experience from operating production service provider networks. Uday is a principal network engineer at T-Mobile with 18 plus years of experience in large-scale service provider environments, specializing in network operations troubleshooting, automation, and reliability engineering. Gentlemen, it's a pleasure to have you both with us today.
Thank you very much. So good afternoon, and thanks for being here today with us, where we will talk about something that we keep hearing all the time, which is automation. But what's really unique about our presentation today, our goal here is not to talk about how to use automation to make changes to our network, how to use automation to add new services, new devices. We want to talk about automation from a different perspective, where our focus here is how can we use automation to help our network operation team to do what they are doing faster and better. And that's why we decided to call our presentation Automation for Operation. Now, what we are planning to do today is to share with you what we have learned about using automation for operation for a good amount of years now, and how can you apply these concepts in large networks, very complicated networks. What is the right way to start with that if you don't already started with this? What are the things that make sense for automation for operation? What are the things that you have to be a little bit careful about it? So it's mainly about the concept and how can we share these lessons with all of you. The plan is not to talk about specific vendor, specific tool, or any implementation details. It's more about the concept behind using automation for operation. So our agenda for today, we like to start first to talk about the modern operations. What are the challenges? What are the realities? One of the most important concepts when you start with automation for operation team, what are the things that make sense to automate? What are the things that hopefully in the future it will be possible, but it's very hard to automate right away? And how can we move our operation team from manual operation team to automation, where automation can help them to do what they are doing better and faster? Then we will go over some automation use cases, whether these cases are reactive or proactive. And we will spend some time talking about, when we talk about automation, it's not just about building a script and run that script via cron job 10 times per day. What you need to keep in mind that what you should build here is a product. And that product needs to be able to scale with time, because your network will keep growing with time. And when you do something like that, you have always to keep into consideration what will be the right architecture for that product and what will be the right design. Because if you want to really use this to make a difference for your team, this needs to be something that your team can trust and something that you can grow and you can support so that your team can rely on it for their day-to-day operations. And we will conclude with some lessons learned and what's next. Now, before I start, as you just heard now, that I will be doing the presentation along with Uday. We spend very long time now doing automation for operation for T-Mobile, which is for sure one of the largest and maybe most complicated networks in the industry. And what's unique about telecom in general, that most of the data that we are carrying is real time. So latency is big for us. And the biggest challenge for us that we run in our network now 911 calls. So if there is anything wrong about our network, we can put human lives at risk, which will tell you that this network needs to be up all the time, running all the time without any problem. Now, the first thing I like to talk about is what is the current state for operations. Now, to make sure we are both on the same page, what we talk about here is this team that is mainly responsible to support our infrastructure, the IP devices, the security devices, routers, switches, firewalls, etc. And when we look to what this team is doing now and what kind of networks they are dealing with, no doubt that the size of our network grown exponentially and keep growing with time. Sometimes you may have hundreds, thousands, and sometimes you will have hundreds of thousands of infrastructure devices inside your network. At the same time, the reason why we built this network to allow our servers to communicate. And the number of servers that we have in our network keep growing every day. The other challenge that we see with our networks, they are not in one location. They are in so many locations so that you can have the right service for your customers. So our network now is almost everywhere. And finally, when we build this network, we do not use really one vendor to do that. We have many vendors, many products that need to work together at the same time to make sure that our services are working the way that they should. Now, in addition to this, when you look to your network from a software perspective, like when I started with T-Mobile 19 years ago, the concept of forwarding was mainly layer 2 lookup, ARP, MAC, a little bit OSPF, a little bit BGP, right? This was the case for before. Now when you look to the networks, on the top of that, we have MPLS everywhere. We use layer 3 VPN, layer 2 VPN. We have label stack. We run traffic engineering. We run auto bandwidth. When you go to data centers now, we have VXLAN everywhere. So the complexity of the network is way, way higher than what it used to be. Now, what does this mean? It means in order for me now to have visibility to my tool, I can't just use one or two tools. I have to use a lot of these tools. Now, because we use a lot of tools now, the amount of data that these tools will generate is huge. And to be able to handle all that data and utilize it when you need it, when you are dealing with tickets, when you are handling outages, it is very clear now that just using humans and manual process to do your operation is not enough anymore. And automation should become a key part whenever you build any network operation organization. So that's the reality now. We definitely, if you don't feel it now, very soon you will start to feel that without automation, your ability to manage and support your network will be very limited. The other important thing that we have to take into consideration, regardless what network we talk about service provider, enterprise, telecommunication, at the end of the day, we build operation to do two things. Either they will do reactive or proactive. Reactive means something bad happened on my network. Most likely that will generate alarms for us. These alarms need to be translated into a ticket. The ticket needs to go to a specific team, and that team will start to work on it. So that's what reactive is about. And it's definitely a key for any operation team. But operations are not only designed to deal with reactive problems. They also need to deal with what we call it proactive operation. And the main difference here, I do not want to wait for something to become a problem and cause me an impact. I need to collect enough signals from my network to tell me that this area is sick, but not sick enough to cause me an impact. And it's very important now to go and make sure that I get this area to the right state so that I can avoid having any outage from whatever that signal that you are getting. And when we design automation, what we have learned that we need to do it for both reactive and proactive. However, to become efficient and to show the value for your work, usually when you start your automation for operation, first you need to cover the reactive side. And then you can go and start building automation for proactive problems. Now, proactive is definitely more challenging because, as I said, in proactive, your goal is you don't have a problem yet. You want to find what can be a problem and take the right action to fix it. Now, we all, I think we agree that most of our challenges in our network are not because of hardware or software failure. Most of the time, we have outages because of what we change in our network. So when it comes to proactive, we have to take care of something like pre and post validation. So whenever I make a change to my network, I need to make sure that my network is healthy before I start. And what's more important, I need to make sure that my network is healthy after I am done. Proactive will include something like end of life, end of support. I need all the time to know what are the devices that will hit end of life, end of support, so I can take the right action for them. Proactive will include something like code. Do I have the right code on my devices? Do I need to do any upgrade on them? And one of the big areas for the proactive is always verify, and this is one of the big things that we are trying to deal with these days. How can I confirm that when I build redundancy, because our goal is to avoid a single point of failure. The only way to do that is to implement N+1 redundancy. So if one device fails, another device can take over. The challenge we are seeing now that we always assume that redundancy is going to work. But in reality, you will have an impact and then you will find out when my traffic moves from A to B, B was not ready to process all that traffic. And this is one of the big areas for proactive analysis, where your goal here is to always make sure that you have the right redundancy state so that when you have real failures, the network will be able to behave as expected or as designed. Now, the two main metrics that you always need to keep in mind, the same metrics will be applied when you start to do automation for operation. Our ultimate goal at the end is to make sure that our MTTR, the mean time to repair, will be as short as we can. We do things fast. And at the same time, our mean time between failures, we need to make this as long as we can. We do not want to have an impact every day. We need to have good amount of time between our problems or between our failures. Now, as I mentioned, when you design automation for operation, these are the two areas that you have to deal with. How can I build automation for reactive functions? How can I build automation for proactive? Usually proactive will be more difficult because, again, there is no problem yet. You need to collect enough data to tell you if the problem can happen and then take actions on it. Okay. Now, before I start talking about how to do this in action, like one of the main challenges that we faced, and I am sure anybody doing automation will face the same problem. When you talk to your team, to your leaders, one of the areas that will be very hard to talk about is what's the difference between automation and what automation can do for us and AI. and what AI can do for us. Because everywhere you go now, people are only talking about what? AI. And so many people now, they mix between when my problem should be solved using automation tools, when my problem should be solved using AI tools. Now, from what we learned so far, and I will keep it simple as much as I can, when you have a problem that you want to solve, and you want to solve this problem using some sort of coding, whether it's automation or AI, you can say that this is more automation as long as this problem is deterministic. I can build a mathematical and logical model to solve it. And what's really more important, when you use automation, whenever I give you X, you will give me Y. Your output will always be the same. When we talk about something like AI, AI is different. AI is a model that we build to learn with time. Learn means the problem that I need to fix with AI cannot be deterministic problems. So when I build an AI system, my expectation is if I give you X today, you give me Y today. If I ask you the same question in 2 weeks, I will expect you to give me a different answer. Why? Because you are supposed to learn and update how you figure out the solution with time. So the confusion that you will see now, that a lot of people think that automation and AI are the same. A lot of people believe that everything is AI problem, and there is no need for automation. And this is something that you have to make sure that you make it very clear for your team, for your organization, that what I can do to fix my problem is either going to be automation or it will be AI. It can't be both. And for infrastructure, maybe this is different for servers, for coding, for software development, but when we talk about infrastructure, 80% of your problems will be automation problems. Maybe 10 to 20% of the problems will be AI problems. And the way that this should work, that you need to have enough automation tools running in your network that can generate the data that hopefully later on you can use it for AI system to start utilizing AI for your operation teams. So that's a very important difference that we have to keep in mind. So let's now talk about, when I talk about operations, what are the different functions that my operation team is doing that makes sense for automation? Now, before I go into that, again, keep in mind, we talk here about network operation, the team that is responsible to manage my infrastructure, not my servers, not my services, not my applications. The other thing that we need to keep in mind, that this team is either doing a reactive work or doing a proactive work. Now, if we start with the reactive work, what we know for sure that regardless what operation we talk about for what business, at the end of the day, the key idea here is when something bad is happening, my network should generate an alarm for me. Maybe that alarm will be generated by NMS, SNMP protocol. Maybe it will be telemetry. Maybe this alarm is generated by a tool like SEV1, like NetFlow tool. Maybe this alarm will be generated by a syslog. At the end of the day, operation team will see alarms. Now, the challenge we see these days is how many alarms we can have at any time. And usually, you will see that when I look to my alarms, I will see a lot of them. Why? Because one of the challenges with the alarms is one alarm can generate 20 alarms with it. Like, for example, the link go down on my router. What will happen? My link will go down, HSRB will go down, If you run OSPF over that link, it will go down. If you run BGP over that link, like eBGP, it will also go down. Your LDP protocol will fail. So now this one alarm will generate to us a lot of these alarms. The challenge we see with our NOC now, and I'm sure everybody is seeing it, if I will go to each one of these alarms and translate that into a trouble ticket and send it to the NOC will be dealing with so many alarms that they do not have enough resources to deal with them. This is one of the great areas for automation, and Uday will talk in more details about it, where the idea here is, before you route any of these tickets to your team, you can build an automation engine that can look to all these alarms, find what alarms are related to each other. This is something we call it alarm correlation. Then find out what I can clean from these alarms. And then after you run all that cleanup, the final list you will have, you can now move to the step number 2, which is to translate these alarms into tickets and then route them to your NOC or to your operation team. The other challenge that you will have that is related to this, one of the most difficult times to process alarms will be during maintenance window. Why? Because during maintenance window, so many people are making changes. It's normal for this link to go up and down because that's what the change is going to do. We reload devices for code upgrade. That in its own will generate tons of these alarms once they decide to reload it. So one of the areas where automation can really make a difference is how can we treat these alarms during the maintenance window in a special way so that instead of flooding our NOC with hundreds, thousands of these alarms during the night, and most likely when they see all these alarms, what they will do? Nothing, because there is no way they can process all these alarms during the maintenance window. But what we can do here is to do this alarm correlation and alarm noise filtering to make sure that we take into consideration that this is a maintenance window. This alarm can be really a result of a change. And if this is the case, no need to send all that noise to the NOC unless you are sure that change is done and this alarm is still valid and I should send it to my NOC so that they can deal with it. So this is one of the areas where automation can make a big difference, especially for your NOC who are dealing with these alarms every day. Now, once the alarm is generated, what do we do next? We need to translate that alarm into a ticket. And then we need to send this ticket to the right team. Now, when you do that in a manual way, the problem that you will have here, you need to wait for someone to take that alarm, make it a ticket. Hopefully, he will add some good information to it. Most likely, he will not have time for that if he has to deal with so many alarms. And then he needs to route it to the right team, and the right team will start to take action on it. This is another great area for automation for operation, where I don't want my engineers to do that for me anymore. I can build a tool, I like to call it a product, that will finalize these alarms after all the correlation, all the noise filtering, and then he will translate these alarms into tickets. And what's really good about automation here that I can go and collect all the information that I need for that alarm, for that ticket, add it inside my ticket, then route it to the right team. So when the engineer will see the ticket, he will have enough information to know how to start. So this is one of the areas that automation can make a big difference when you are dealing with tickets. A third reactive area where automation can help a lot is how can we utilize automation for outage detection and outage response? Like one of the challenges that I believe everybody will have, most likely when you have an outage, you need to wait for your application team or your service team to complain about it. So they will call you and they will say, this application is failing. We think it's a network problem. Then you will start to take actions on it. what automation can do for us here is to collect enough signals all the time and try to find out if any device is not working as expected. So now I can detect the outage before anybody can call me to tell me that there is something wrong about your network. You need to work on it. Now, when it comes to reality, if you try to do that, the challenge that we will have, and this is something that you have to take into consideration and find what's the right way to fix it based on what network you are dealing with. In order for me to be able to detect non-functional areas on my network and understand if these areas will cause me an impact and how big the impact will be, the challenge for us when we build a network, we really build highways. We have very limited visibility. Who will be using or what application will use what path to go from A to B? So what you can utilize, which can be maybe sometimes if you have a small or a greenfield network, it will not be that hard. When you are dealing with big network like our network, this can be very challenging. But one of the areas that you can utilize automation for here is to track what devices in your network are used by what application. In this case, when my router is not working, there is something wrong about it, hardware failure, software failure, I can tell right away that this device is used by these applications. I need now to call them and let them know that their application, their services may be impacted because this node is not working as expected. This is one of the great opportunities that you can get to by using some sort of automation, because there is no way to do that in a manual fashion for so many reasons. Applications keep growing every day. Applications change their behavior every day. So unless you can build something like automation to track applications and what they use, doing something like that will not be easy. But at least now you have maybe a path where you can detect your problems. You don't need to wait for others to tell you what are the problem, or you have a problem or not. And you can, more important, detect how bad the problem is, so I can take the right action on it. The other area for automation, as we all know, after we have an outage and we find out that we have a bad configuration in our network, we need to know what devices will have that bad configuration. We need to fix this bad configuration as soon as possible. This is another area where automation can make a big difference for us, because it is very hard, especially if you have this situation in many devices, to go and create changes manually and run them one by one to get this problem fixed. And this is another area where automation can make a difference. Here you have to be careful, because now we talk about using automation to make changes. So you have to be very careful about what automation should do here. Is this safe, or is this change will be safe? Can I make things worse by doing that? But at least now you have an option that I don't need to wait for my team to spend 2-3 maintenance windows to get my issue fixed. I can utilize automation to get that fixed in one night, and we are done. So everything we talk about here is really reactive. The other area where automation can make a big difference is proactive. Like, for example, as I mentioned, most of our outages are generated by changes. Proactive can help me to automate pre and post validation. That's a big area for automation. Compliance, and verify that my network is configured based on my design. Another good area for automation. Validating capacity, redundancy, that we will talk about more later on. And finally, to use automation sometimes to find, like especially when you have a bug and you need to do some work around to fix it, instead of waiting for somebody to log into the device and to act, I can really automate that process. So I can monitor whenever that bug is triggered. I can use automation to go and take the right actions without waiting for my engineers to do any of that work. So that's what automation for operations can help with. The next part will be covered by Uday, and he will start to get us more details about real cases where we can utilize automation for.
Thank you, Isa. Good afternoon, everyone. Thank you for being here. Our journey can be tracked back to the simple operations problem, the most common problem we all face. It's 2 a.m., you get paged out, someone is throwing you an IP address and requesting you to investigate. What is the problem with this one? Our entire journey can be tracked back to address that simple problem, how to address that efficiently, really. That's where we began. To do that, we need to establish a network state that is searchable, that is reconstructible. That is our whole goal. That's how we got started really into all this. We found out through all our experiences that we need a good foundation that is building good visibility into the state of our network. When you're scrambling to troubleshoot something and you're accessing these machines and trying to track your routing tables, trying to track your ARP tables, MAC tables, you're only hoping they haven't aged out. But if they do, you need to have some kind of snapshot, some kind of visibility into your network, right? And even before we jump into anything automations, we need to build that strong foundations before we even jump further. So our journey can be categorized into 3 phases, really. The phase 1 is visibility. Phase 2, depending on that visibility, add some intelligence into that visibility. Phase 3, basing on these 2 as the strong foundations, now start building automation at a scale. That's how everything falls together at the end. Jumping further into the phase 1, really making our network observable. Going back to that same use case, when something ages out, it would be so lucky to have a snapshot, a quick snapshot to find something, especially when you get called out few hours after, where your tables have aged out. It would be so easy and efficient to find out the broken application IP address was being learned from this particular interface, and now that is in a problem state, and that is why we are facing this problem. For example, a basic example, right? Building that visibility phase really makes a big difference. And when we have a state that is trusted, a trusted network view, that's what makes our decisions more reliable at the same time. Now that you have a snapshot, let's assume you have a daily snapshot of your network, but that would not be enough as we go further. As the scale increases, as the amount of complexity in our network increases, having just a single snapshot is no longer helpful. Now you need to add some intelligence into it. You want to capture the time difference and what state changed from what. For example, from yesterday's to today's. Did our configuration change? Did our routing tables change? Did our interface statistics change? ARP tables change? When you add this kind of intelligence to the snapshots that you're capturing, now that makes it even more advantageous when you try to build any automations based on this. So when you have these 2 together, that's when we can start building automations at a scale by having a trustable, a reliable network view snapshot along with your command line information. Combining all these things together now makes you more powerful, more reliable, and trustable at the same time when you're implementing something from the automation standpoint. That's where our phase 3 really is called enablement, which is simply automation enablement at scale, utilizing all these things. So specifically, when we go into a little bit more examples in this, it would be something like KPI calculations, health check calculations, what Isa was describing earlier, integrating all these informations, using that intelligence, using the time capture, the diff capture, everything, integrating all that into automation. That's what makes it even more powerful and very knowledgeable decision making at the end, with a safety guardrails that are all included into this. Now, how does all this really help with NOC automation? So when we talk about our frontline teams, the tier 1 that is handling thousands of alarms per day, we need to bring all this information together and help them out. Even if the team is staffed 24/7, handling 7,000 to 10,000 alarms a day is not easy, especially when they get a burst of alarms during the maintenance. We wanted to utilize all this knowledge, all the foundations we have from previous 3 phases, and utilize that, really help our teams out, help them focus on the most critical alerts, filter out the noise. That way, they can really focus all their efforts on finding the most critical thing that can impact our customers. At the end of the day, that is our goal. Make sure we meet our mean time to repair, make sure our SLAs are met, and make sure any outage is invisible really to the customers, right? That is the whole effort, the whole goal at the end of the day, for the reason for doing all these things together. And when we talk about the various scenarios across which we can apply all these automation ideas, going back to the same division, the reactive versus proactive, I'll dig a little deeper into the reactive scenarios. When we talk about the reactive, think about the alarm. Same way, a simple use case, again, interface down, BGP down. We have received some of these, and people are always starting, the engineers are always starting with basic fact gathering, or it takes time to access the devices, collect the logs, stitch them all together, prepare a story, and then you start into the actual investigation or troubleshooting of what happens next, who do you engage next, etc. Right? Instead of all that, now with automation enablement, as soon as an alert is generated, especially when you're reacting to an incident, we are able to capture all required information, all the fact gathering, all the data gathering, everything is collected. It has already been enriched with all possible information we can get from our snapshot, the diff, all the state differences we have observed for a given device or the set of devices or the even path completely in some scenarios. Combine all of those already into a summary and attach that into the work log. That way, you're already providing an enriched context to the operator or the engineer who is actually starting that first step of troubleshooting. You're eliminating 10 to 15 minutes of time, which makes a big difference, right? We need to beat those mean time to repairs. We need to improve our service level agreements, and to do that, we need to provide anyone involved in the path, any human that is involved in this whole system, we need to provide them the power and the knowledge to start ahead, give them a great head start with all the knowledge possible, right? Wherever you are unable to make an action, let's say, in the earlier case, let's say your automation was able to take a auto-mitigative action and make sure there is no service impact. But there are always cases where you're unable to take any actions, but even in these cases, like I was describing, you're still able to enrich and provide that powerful summarized information to the operator to make sure they never lose any of that initial 10 to 15 minutes with basic fact gathering or any of those examples. Then comes the bigger problem, like Isa was describing, we are getting hundreds and thousands of alarms, depending on the scale of your network, hundreds to thousands of alarms during your maintenance windows. So how do you handle that? That's where it really boils down to correlating these incidents together, filtering out the noises, helping our NOC operators really focus on the root cause of the incident, but never the symptoms. Same example, interface down. Let's assume the interface is part of a bundle, a lag. So when an interface goes down, you get the interface down, you get the bundle down, and depending on some of the device types, the vendor types, you also get bundle degraded as an additional alarm informational. If you had any dynamic protocols, BGP, OSPF, ISIS, BFD, any of these traversing, if they were traversing the problem link, now you get 4 additional alarms. So one single interface down has now resulted in almost 8 alarms altogether. And if you're trying to address independently all these alarms one by one through automation, that does not scale. We are talking about eventually a sum of hundreds and thousands of alarms throughout the year. We need to be very smart about this, combine them into one single root incident, where everything else becomes simply a side effect, a symptom of the root cause. That became the biggest challenge, really. And the most impactful work, the results that we have seen, has come out of this one, out of creating a correlation, deduplication, noise filtration. So once you have these visibilities, all three phases, you have a snapshot, you have a trustable snapshot, you have a good foundations, you have automation ideas, everything implemented, it no longer stops with your NOC. The way we have seen it evolve is it started helping out many of our sister teams, many of our peer teams. Everyone started taking advantage of the data points we have now. They were able to, for example, our IT application teams and our security teams now were able to take advantage of all the data snapshots we have, and they were able to integrate that with their own analysis. Because IT applications or any other teams, they do not have a complete view into network. But by making that visible, by making it transparent, by making it shareable logic across many other teams, it became so helpful for all other teams to easily integrate with our data points, either through using our centralized database or using our API calls. It became so much easy for all that integration at the same time. Same thing with external partners. When you're having SLA discussions with external partners, it becomes so hard to see that common point. But we were able to create a transparent, common, shareable knowledge data viewpoints, which makes it very easy for those kind of discussions. Anything that, without sharing anything internal, anything confidential, you're still able to share a transparent view of a snapshot of the network with any external partners that you're working with, any circuit level discussions, any SLA agreements, any of that. They became very easy with all these snapshots and the knowledge building, the foundations that we had for these things. Same way for our engineering and vendor accountability, they were really helping proactively track many of the software changes, the hardware changes, anything that were happening because of all the snapshots we had in the network. We were able to provide very easy auditing capabilities for our engineering teams and our vendor teams at the same time. Going a little further into the actual use cases. So I took interface error scenario as one of the most common use cases that many would have dealt with. It is a silent alarm. The device itself usually doesn't generate an alarm that one of your interfaces is taking errors. But if left alone, and if you have a sensitive application traffic that is traversing this particular interface with errors, it can create cascading impacts. It all depends on how sensitive your application that is traversing that problem is. So if you think about the whole process, how are we building everything together? All the ideas we have shared today, how is that coming together to address, let's say, something like interface errors? So we start with the first step, which is the signal and detection. So getting awareness of this. So it could be from telemetry or any other SNP polling tool or any other form of detection mechanism, really, that suddenly now identifies one of your critical nodes, one of your critical interfaces has started experiencing errors. Now from there, that detection could be converted into an alarm, which is forwarded towards your NOC. But we are also interfering with that process here, and we are able to auto-incident that, meaning you can take an alarm and auto-ticket that incident or auto-ticket that alarm and trigger your automation process automatically without even waiting for any human in the loop, right? That's what makes it easy, that faster detection and faster identification and collection. Basically, that's what is happening here in the background. And once orchestration has been triggered here, you could be managing a central orchestration which is running all these things together. Now it gets notified that so-and-so ticket or an incident has been created for interface errors from one of your devices. Now it is able to pick that up and collect your basic facts to begin with, the device information, interface information, the bandwidth capacity, basically the data enrichment, and pass that information to your backend decision engine, either through APIs or any other effective form that you would use within your company, right? Once the actual decision engine is triggered, now this is the logic which is handling our interface error, let's say. Now that decision engine has all the facts, the ticket number, in interface information, device information. Now it is digging further into checking all the safeguards that you have defined. Do you have the authorization first to act on this set of device? Is this a confidential device? Is this allowed to act upon? And then other safeguarding rails could be, do you have enough redundancy? Do you have capacity? Are you even allowed to take this link out? Is there a minimum link configuration, for example? Something that will stop the automation from even removing the link. All these safeguards will be considered. It will look at the live state, the live configuration, and then take an informed decision based on all the safeguards that have been configured so far. That's what makes it, at the end, that final decision is based on all the safety guardrails, all the knowledge, all the visibility snapshots that were built. Everything comes together at this. And you could think, where does actually snapshot come into the picture here? This is where, let's say, the interface is part of a bundle. At this moment, let's say the interface only contains 5 or 6 members. Let's say it contains 6 members, and the 6th member is the problem link. The visibility snapshot will give you an idea to make sure you are actually in a healthy state. Let's say when the script actually logged in, when the automation actually logged in, and it identifies that the bundle currently contains only 4 members. Now, based on our healthy snapshot, it already knows we are short by 2 links. A healthy bundle should have contained 6 members, but we are already at 4. Now, this is what triggers additional lookup into the capacity and redundancy analysis to make sure if you are going to remove the problem link, can all our remaining 3 links handle the capacity? So you need to be very safe when you're allowing your auto mitigations to take these actions. So that's where the safety comes into the picture. How clearly do you define all your rules to make sure you never break, the automation should never become the reason for additional outage or a additional service degradation, because now we have oversaturated the link by, even though we are taking out the problem link, right? We need to either make an informed decision of being able to remove the link, or let's say you could change the cost of the link to divert it completely to a different lag bundle. So that's where all the informed decisions come into the picture, which will lead to the automated mitigation. And all the evidence is captured, summarized as a pre and post changes. And it is posted into the work log as an enrichment for anyone to look at the summary. At the same time, you can always alert all your teams, anyone who's interested, through Slack notifications, Teams notifications, or email summaries, whichever makes sense for anyone who wants to receive that information. So the real goal is recovering our network as fast as possible, making that outage, making that interface error scenario invisible to any of the customers. Going a little further into the actual safety guardrails, right? Authorization that I was talking about, you could define if the device is eligible for automation or not, depending on the network type, but depending on the applications that are traversing a specific device. You may not want automation to act on every type of device, every type of interface. This is where authorization comes into the picture. And redundancy. Going back to the same example, do you have enough redundancy? Do you have enough healthy links that are able to take over all the traffic when we remove that problem link? And you could perform through the command line, is the problem real right now? Let's say in a worst case scenario, there is a possibility where device could falsely show interface errors. We have experienced this where errors from a different interface were propagated and reflected across other interfaces. In reality, they never had the problem. But because of the detection process, you may falsely see some of these alerts generated, and you cannot let your automation blindly start taking action on all these interfaces at once, right? So you need another safeguard in the picture to make sure the errors are incrementing live. That's what adds that final check to make sure it is a good decision, it is a safe decision for the automation to make at this point. Capacity, again, are all remaining links able to handle all the traffic distribution once we take out the problem link. And then the go, no-go condition that happens based on all this together. Before we look at the auto triage, how does that happen? Let me also describe you a little bit more details on the correlation and deduplication we have been talking about. Same process, you could, let's assume you're talking about a bunch of incidents or alarms, either way, bunch of tickets or alarms. You could have a process in place that is monitoring all these together, and the central orchestrator now can understand, I have received 10 incidents from router 1. I have received 10 incidents from router 2, 10 from router 3. in our old days, if we let automation act independently, now the script is logging in 10 times to each device to handle each alarm independently, right? That is what cannot scale. Especially as our network complexity keeps growing, we cannot act independently across each one of these alarms. Correlation had become such an important factor for us to bring that value overall through all these automations. Is now out of all these, we only required 3 actual SSH sessions out of 30 alarms. That boiled down to really that, bringing it down to the least minimal resource utilization and highest value out of everything that comes together out of that. So step 1, intake, meaning get the list of all the incidents, all the alarms that consider maybe last 15 minutes of snapshot. What happened in the last 15 minutes? You received a list of alarms, and now you want to understand, can we group them together? You are specifically applying filters to make sure this is a queue. Let's say it's called automation queue. That is where you're holding all these tickets, let's say that. And you want to make sure this is the queue that you want to act upon. You don't want to touch any other critical queues, something that is already in progress, something that is already being worked upon. So you could hold them all in a temporary queue called automation queue. And that's when you can apply all this correlation logic together. Based on all the incidents that have been created, all the alarms that you have received, you can identify shared identifiers, canonical identifiers, something as simple as a device plus interface. You could apply the same logic across any type of alarm. Let's say you received 1 interface down, 2 BGP down, 2 OSPF down. If they were all sharing the same problem interface, now you have a shared identifier across all of them. Now they all form one cluster in step 3, the correlation graph. You have identified a cluster of 10 incidents together. Out of that, now your logic is now coming down to what is the parent incident? What is the root cause here? Let's say our bundle went down, and we have now received 10 different alarms for 10 different interfaces and BGP and OSPF. Out of all those, we clearly, going through the hierarchy, we identify a bundle down is the root cause that has resulted in 10 different child alarms or symptoms. That hierarchy is what is defining which becomes the parent incident. Now you know which one to focus on, where to collect all the information, which is the main device that you want to log in on. At the same time, you're receiving all this information from your peer, the remote end as well. And if you manage the remote end, you have the permissions to log in and collect the data. Now you're able to correlate them all into a single cluster too, because the same interface has become a shared identifier even for the remote device now. All of them, 20 alarms now have become part of a single cluster. You only need 1 or 2 SSH sessions to make sure the local statistics are gathered, the live statistics that is, and the remote live statistics are gathered. That's what decides that parent election using that hierarchy. And in many cases, we have seen the same interface being reported through 2 or 3 different alarms. This is where the deduplication happens as well. Suppress all that noise, remove anything that is simply redundant information, keep it as minimal as possible, and let our NOC focus on that one true root cause, eliminate everything else. Using all this knowledge, interface down, BGP down have always been the top noisy alarms. That may apply for many of our networks if you have gone through the amount of alarms you receive. And if you look at the overall process, how we are dealing with these ones, especially where auto-mitigation cannot be applied. Because if an interface is down, automation can't really bring back the interface if there is a layer 1 problem. The NOC needs to work with actual site technicians and perform layer 1 troubleshooting to restore the link, right? There is nothing much automation can do at that point. This is where we still provide value with the data enrichment, the correlation, the deduplications, and the noise filtration, right? You're going through a bunch of alarms together, interface down, BGP down. You identify them all together. You identify the shared interface between all of them together, group them, identify a cluster, identify the parent out of that cluster, and process all the information, gather all that evidences, anything that could be useful. Some cases, let's say it's a circuit towards a vendor. Now you're able to also gather the billing information. What is the circuit number? Something that you would need to open a case with your vendor. Instead of losing even those 2 to 3 minutes that a person would need to look up, go to a centralized page, look up your vendor information, the circuit information, your automation is now able to capture all this information that can save the person up to 15 minutes. That cuts into eliminating or reducing that MTTR and SLA agreements really. Isa, you want to take over for this one? So this is again a proactive example where the same knowledge can be applied.
Yeah. So what you see here, guys, is something that we were building for a long time, where how can I use automation to make sure that my redundancy is behaving as expected? Because what we keep missing, that we add N+1, we add redundant nodes, redundant links, but how can I guarantee, how can I have a confidence that when this node is failing at 2 p.m., the other node can take over? So what we did here is we built an automation that will go to our network and validate redundancy is working as expected. And this is one of the great examples of the proactive work that you can do within your operation team. Now, it looks complicated, but in reality, you need to do 4 major things here. Number 1, based on my knowledge, based on my understanding, I need to identify where redundancy exists in my network. So in most cases, you will see that whenever we build router 1, we build router 2 to be redundant. When we have switch 1, we have switch 2 to be redundant. When we add link to switch 1, we have another link to switch 2 to be redundant link. But this is the key information that you need to start with to be able to do something like that via automation. Identify where your redundancy exists. In many cases, this will be local within the market, but there are good amount of cases where your redundancy is not local, is geo-redundancy. ISP links, for example. When ISP link in site X is down, my traffic will go to the ISP link in site Y. So based on how you build redundancy, you need to identify your redundancy pair. The next step, which is really the core of the whole process here, now I know that I have R1 and R2 as a redundancy pair. What I need to do now is to go to R1 and go to R2 and collect all the KPIs for all the protocols that are important to run my service, to run my redundancy, to run my forwarding. Once you collect all these KPIs that can cover what we do in layer 1, 2, 3, up to 4, now you start to compare what's the KPI state for R1 and R2. And when you see a difference, you need now to decide, is this difference enough to cause my redundancy to fail? So maybe I should mark it as red or orange, or this redundancy or this mismatch between my KPI is not great, but it is not going to impact my redundancy. But I still need to mark it so my engineers later on, they know something is wrong here. You need to go and work on it. And if you see a match, then you know that your redundancy is in a green state. You can rely on it. And the last part here is, once you identify all that information, you need to take actions. That's why, as I mentioned, this is a proactive. I can notify my engineering team that the redundancy here is not working based on your design, based on what we expect. Please go ahead and fix these issues so I do not have an outage when router A is failing or router B is failing. At the same time, this can be a great information for our change management team. So before they decide to reload a device because maybe they want to do migration, they want to do a code upgrade, they can build that confidence that when I take router A down, I know router B will take over. Redundancy should working as expected. So this is one of the examples where you can deploy or utilize automation really for something like proactive work. Our last section will be covered by Uday, which is the architecture that you can build to support such an effort.
Trying to wrap it up. So now where do you actually begin with all this information, right? Layer 1 goes back to utilizing some kind of either a virtual machine, containers, bare metal. So it all depends on the scale of the network, the amount of automation, the amount of devices that you want to handle at a scale. Right? That's where the decisions come down to. And we are simply listing all the factors that we considered while building these things, and hoping by sharing this, that gives you an idea when you're on this journey, what are all the factors that that could be helpful in your decision making. So along with the bare metals, and next becomes the making sure these virtual machines or the bare metals are actually in a place where they can easily access all the network elements that you want to perform automation against, and making sure these VMs have enough resources that there would be no contention issues, etc. Next comes for your phase one visibility or the snapshot collection. Will these be enough for your data collection, for creating that snapshot? You don't want the same resources fighting for automation, for collection. There needs to be a separation of resources so that they are never in contention. There is never an issue where automation is fighting for resources when the same machine is fighting for collection at the same time. So we don't want them overlapping. It would be efficient if you can separate them out. That way, every automation, every process workflow has its own resources. There is never any contention, and everything can work without any interference. That will also lead to effective centralized storage. You could be relying on a centralized database, for example, instead of relying on any MySQL local tables or anything hosted on a VM. Something like a centralized Snowflake, as an example, something that will always be available, always on. That's what will make a big difference. Historical state snapshots and any KPIs that you have gathered out of all these collections. Again, they all go back to the same centralized database. You need something that is constantly writing and updating your database tables with all this information that is being collected. It could be every 5 minutes, every 10 minutes, every 15, 1 hour, depending on your operational state. While handling it as an automation, your central orchestrator should be the one that is processing all this in parallel and in batches, never again fighting for resources. The same machine orchestrator could be handling correlation, deduplication, deterministic logics as well. When you're building all this, again, there must be reusable libraries, reusable modules that you could share across multiple teams. It no longer belongs to your own. You could be helping so many of your peer teams with all this knowledge building, all the information that you have. Layer 4 comes down to bringing it all together, where you could be relying on auto-ticketing, processing of all these auto-tickets, automating, taking decisions, and integration with all possible workflows together with existing things in place. The challenges really what we faced were coming down to that resource contention. That was the biggest challenge we faced. It was a trial and error. We were getting started, and as we figured out, the most effective way to use is containerization, right? That treat them as microservices, keep them all separate, assign them all their this is pure software engineering. We coming from network engineering mindset, you would not think of software engineering at this time. You're thinking of solving a problem immediately, quickly, by writing a script. But just developing a script is not a solution for us anymore. It needs to be a system, which is a combination of multiple things. It could be like agentic AI agents that are controlling, a central orchestrator that is controlling a bunch of things to make all this happen together. It's no longer a collection of individual scripts that are going to work as we scale, as our networks become complex. So these are some of the challenges we faced. Since we're running short on time, I'll move ahead. But future really, the way we think about it, where everything that we're doing right now, we can make it even more powerful by integrating with AI models and getting even efficient hypothesis or efficient summarized versions of anything we are collecting, because we have snapshot, logs, all forms of data points. We just need an efficient way of summarizing everything. That's where integrating with AI makes all this even more effective. As we go further, we think about utilizing or being in a hybrid state where everything comes together with the AI enhancement, the rapid development we are seeing. It's just amazing to be involved in this phase where we can be in this hybrid state at least for a few more months, maybe. I don't know how long we'll last in this hybrid state, but the way AI is developing, right? We need to take advantage of that. There is no doubt. And there is no way we can still eliminate everything. We can't become autonomous overnight, right? It takes time. While you're surviving in this hybrid state, that's when we take advantage of AI and keep working out any other inefficiencies that we see. But thank you all for being here. I'll end here, and we can take any questions if there is time.
Yep, absolutely.
Yeah.
Isa and Uday, thank you. That was fantastic. We are a little over on our time. I know there's more talks going on in the grand ballroom, so if anyone needs to leave, we might be able to take a couple questions if there's any right now.
Yeah, go for it, please.
Hey, I'm Santosh from Cisco Systems. So first of all, great sessions. You touched on all important and valid points when it comes to automation. I would like to touch on the reactive automation point of view because let's say there's an outage or issue. I generally ask my team to rely on 3 Ws, where, what, and why. Where's the issue,
Yes.
what component is having problem, and why that component has problem. And why is something which is really important because from my point of view, the issue should be seen only once, and after that it should be just fixed and should not be seen again.
Right.
So is this something which you looked into and dive deeper because why requires a lot of effort, like capturing a lot of logs, working a lot with the vendors. So any insights or any recommendations?
Want to go
Take
for
it?
it again?
Going back to that same interface errors, these some of these examples are out of your hands, right? There are always cases which you can definitely find out the why. Let's say there is an MTU mismatch that happened that caused BGP flapping. You know the why exactly, and you can avoid it. Even if it happens, automation just fix it like that. There are cases like that. But in interface errors, you're dependent on someone else. There is a third-party circuit. There is a third-party person involved which doesn't belong to your own anymore, let's say. And this is something you cannot resolve without engaging them, without relying on someone else's assistance. So that's where it becomes complicated, where you take auto-mitigative action to make sure your service is good, it is fixed as quickly as possible. But for the actual troubleshooting, the actual resolution, you need to still work with someone to fix that why. So there are cases depending on that.
I think that the way you look to it, one of the key factors for us is MTTR. We all agree on that, right? If you monitor what your team is doing during the outage, you will see that 50 to 60% of the time is consumed where? Data collection. They need to log into Splunk. They need to go to Civ1. They need to collect data here and there. If you can save them that 60% of that time and give them that data with better filtering, you can remove the noise from it. They don't need to do it. They don't need to worry how to use Splunk to access these logs, how to use Civ1 to access. You do all that via automation. That 60%, if you can save it, that's a great win for operation because that's really what matters for us. We cannot avoid outages. But what can we do to reduce MTTR? That's where outage can be a great source of information during outages.
Yeah, learn the lessons basically and reapply wherever possible. Yes, thank you.
One last question.
This is Navendu Sinha from Extreme Networks. I design switches, right? And I kind of write specs for the Gnosis. So we are probably the source of a lot of noise for you. So looking at your business problem, right? Yeah. Is there a possibility of working with you to come up with perhaps a business level spec that perhaps we could look at, right? As designers of switches, wherein we try to address some of your business problems instead of, because when I look at you saying that there's a lot of noise, you need to filter it out. Perhaps that is us, perhaps not generating so much of data for you, perhaps processing some of that on the switch itself, so that
that will be a great way to look to it. Do not even let us see the noise. Yeah. Try to run that intelligence at the node. This will be the best case scenario.
Fixing at the source will be the best way, yes.
Yeah. So perhaps as an extension for you to perhaps think about it so that we could work.
Yeah. I think for us, it really depends if you are using really open switches on your environment or not. But I think a lot of customers are still using vendor switches that they cannot really change their behavior. But I agree with you. That's a great opportunity for people who are designing their switch themselves through software, because the more you can do that at the edge, the less noise we get, the more efficient we will be. That's definitely a great area to look to.
Yeah, good question. Thank you.
Well, Thank you very much, guys.
Thank you.
Thank you again, Isa and Uday.
You're welcome.
Really appreciate your contribution.
Absolutely. Thanks a lot.